Ladies and gentlemen, so you're given this question regarding a particular concrete mix. There's the mass of cement, which is 410 kg, the water to cement ratio. The client desires that to be 0.4. You're given the density of water and also the density of cement. Now the question asks you, part 1, to calculate the mass of water required in the mix. How do we do that? Well, the first thing that you need to do is you need to write down the relevant equation, and the relevant equation over here is the water to cement ratio equation. So water to cement ratio is equal to the mass of water divided by the mass of cement. Now, if you were to plug in the numbers that were given, so we do know that the water to cement ratio is given as 0.4 in the question. We don't know what the mass of water is, so I'll just leave that as a letter. And I also know that the mass of cement is given as 410 kilograms. As a result, in order to compute MW, all I do is just cross multiply. So I have that MW is equal to, and that's the first cross multiplication, is equal to the second cross multiplication, which is 0.4 multiplied by 410, and that's equal to 164 kilograms. So that's the mass of water that I need in my concrete mix in order to achieve 0.4 water to cement ratio. Okay, let's have a look at the second part of the question. So the second part of the question, you are required to calculate the volume of water required in the mix. Now again, start with the relevant equation. So the relevant equation in this case is density, which is given the letter rho, is equal to mass over volume. That's the relevant equation. Let's just write that in terms of water. So rho water, density of water is equal to the mass of water divided by the volume of water. Now, in terms of the information that we have in the question, I know what the density of water is. I know what the mass of water is, but I don't necessarily know what VW is, and that's what I'm required to calculate in this question. Let's just plug in the relevant numbers. So your density for water is given as 990 kilograms per meter cubed, and that's equal to MW, which we calculated in the previous step, 164, divided by VW. Again, we need to cross multiply, so that the 1 to one side and then VW to the other side, and what we do end up with is 990 multiplied by VW, that's equal to 1 multiplied by 164. So VW is equal to 164 divided by 990, and you should be getting 0.166 meters cubed. So that's the volume of water that we need in our mix. Now for the third part of the question, we need to do the same procedure, but this time calculating the volume of cement. Again, the relevant equation, rho C, the density of cement, is equal to mass of cement divided by volume of cement. Plug in the numbers that we already have. So I've given you in the question that the density of cement is 3150. So let's just double check that. Yes, 3150 kilograms per meter cubed. That's equal to the mass of cement, which we already know, and that's given as 410 in the question, divided by VC. Now again, you need to cross multiply. So what we end up with is 13150 multiplied by VC, that's equal to 1 multiplied by 410. and as a result, BC is equal to 410 divided by 3150, and you should get 0.13 meters cubed as your volume of cement that's required in the mix. Okay, let's have a look at part 4. So part 4 asks you to contrast the volume of water and cement versus the mass of water and cement. So we notice that if we look at volumes, the volume of water is larger than the volume of cement. Remember, the volume of water that we calculated was 0.166 meters cubed. That's larger than 0.13 meters cubed. Now, if I were to look at mass, it's the other way around. Mass of water is less than mass of cement. 164 kg, which is less than 410 kg. The difference is due to the differences in density. So rho C was larger than rho W. Remember that. So rho C was 3150 in this question, kilograms per meter cubed, while rho C, the density of water, was given as 990. And remember, to calculate the water to cement ratio, it's always mass of water divided by mass of cement. So we don't use volumes, we use mass instead.